Friends, welcome to the class. Today we'll discuss about different types of problem based on section formula. To start with, collinearity of the points. To show collinearity of points, say A, B and C by section formula, let us assume that C divides AB in the ratio k is to 1. Then let us find the coordinates of C using the section formula and then equate it with the original x coordinate and y coordinate of C separately. If the value of k in both the equation are same, then we can say A, B and C are collinear. Otherwise, it's not. Let's see an example. Using section formula so that the points A minus 3, minus 1, B 1, 3 and C minus 1, 1 are collinear. Let C minus 1, 1 divides the line AB in the ratio k is to 1. So using section formula we can write the coordinates of C equals to k minus 3 by k plus 1, 3k minus 1 whole divided by k plus 1, or C1, minus 1, 1 equals to Ck minus 3 by k plus 1, 3k minus 1 by k plus 1. Or equating the x coordinates, we get minus 1 equals to k minus 3 by k plus 1, or this implies minus k minus 1 equals to k minus 3, or this, on simplifying, we get k equals to 1. On equating y coordinates on both the sides, we get 1 equals to 3k minus 1 by k plus 1, or it is k plus 1 equal to 3k minus 1, or on simplifying, we get k equals to 1. That means in both the cases, we are getting the value of k to be equals to 1. So the points A, B and C are collinear. Next is finding section ratio and section point. In such cases, endpoints of a line segment and an axis or a line segment which divides the given line segment is given. We have to find out the section ratio and the section point both. In such cases, first we go for finding the section ratio and then the section point. Let's see an example. Find the ratio in which the y-axis divides the line segment joining the points 5, minus 6 and minus 1, minus 4. Also find the point of intersection. Let AB be the line segment with endpoints A 5, minus 6 and B minus 1, minus 4. Also let y-axis divides AB in the ratio k is to 1 at the point P. So using the section formula, the coordinates of P can be written as minus k plus 5 whole divided by k plus 1, minus 4k minus 6 whole divided by k plus 1. Let this is first equation. Since on y-axis abscissa is 0, that means the x coordinate is 0. The x coordinate of P will be 0. So we can write minus k plus 5 whole divided by k plus 1 equals to 0. Or in other words, minus k plus 5 equals to 0, or this implies k equals to 5. So we got the ratio is 5 is to 1. Now putting the value of k, we can get the coordinates of P. So putting the value of k in equation 1, we get the coordinates of P to be equals to minus 5 plus 5 whole divided by 5 plus 1, minus 4 into 5 minus 6 whole divided by 5 plus 1, or it is nothing but 0, minus 13 by 3. Hence, the required ratio is 5 to 1 and the point of intersection is 0, minus 13 by 3 is the answer. The next one is finding unknown vertex of a geometrical figure. Let's understand through an example. Find the coordinates of a point A, where AB is the diameter of the circle with center 3, minus 1 and the coordinates of the point B is 2, 6. Let's draw the picture. So as you see in the picture, AB is the diameter of the given circle and C be the center of the circle with coordinates 3, minus 1. We need to find the values of coordinates of the point A. So given that AB is the diameter of the circle with B 2, 6, let C be the center of the circle with coordinates 3, minus 1. Also let the coordinates of A be x, y. Since C is the center of the circle, we can say that C is the midpoint of the diameter AB. So the coordinate of C is nothing but x plus 2 whole divided by 2, comma y plus 6 whole divided by 2. Or we can write 3 comma minus 1 equals to x plus 2 whole divided by 2, comma y plus 6 whole divided by 2. Or equating x coordinate and y coordinates, we get x plus 2 by 2 equals to 3 and y plus 6 by 2 equals to minus 1. Or this implies x plus 2 equals to 6 and y plus 6 equals to minus 2. This is nothing but x equals to 4 and y equals to minus 8. Hence, the coordinates of A is 4, minus 8 is the answer. Let's see another example. If 1, 2, 4, y, x, 6 and 4, 2 are the vertices of a parallelogram taken in order, find the values of x and y. Given that the vertices of a parallelogram are A 1, 2, B 4, y, C x, 6 and D 4, 2. We know that the diagonals of a parallelogram bisect each other. That means the coordinates of the midpoint of AC is equal to coordinates of the midpoint of BD. So the coordinates of the midpoint of AC is nothing but A plus 1 plus x whole divided by 2, comma 2, plus 6 whole divided by 2, and that of midpoint of BD is 4 plus 4 whole divided by 2, comma y plus 2 whole divided by 2. So here we get 1 plus x whole divided by 2, comma 4 equals to 4, comma y plus 2 whole divided by 2. By equating both the coordinates, we get 1 plus x whole divided by 2 equals to 4 and y plus 2 whole divided by 2 equals to 4. This implies x equals to 7 and y equals to 6. Thus, the value of x and y are 7 and 6 respectively is the answer. Next is finding points of trisection. Before you go for finding trisection, let us understand what is trisection. Trisection means a line is divided into 3 equal parts. As it is clear in the picture, AB is the straight line and P and Q divides the AB in 3 equal parts, that is AP, PQ and QB. This can be done by finding the points PQ on the line segment AB so that AP equals to PQ equals to BQ. Let AP equals to PQ equals to BQ equal to X. So AP equals to X and PB equal to PQ plus QB, which is nothing but X plus X equal to 2X. So AP is to PB equal to X plus 2X is to 2X, which is nothing but 1 is to 2. Similarly, we can find AQ is to QB or BQ equals to 2 is to 1. So to find points of trisection, we find 2 points P and Q such that P divides AB in the ratio 1 is to 2 and Q divides the ratio in the ratio 2 is to 1. Note, if P, Q and R divide the line segment AB in 4 equal parts, then P divides AB in the ratio 1 is to 3, R divides AB in the ratio 3 is to 1 and Q divides AB in the ratio 1 is to 1. And the picture goes like this. That means the first one is nothing but trisection, where 2 points divided a given line segment in 3 equal parts. In the second case, 3 points divide a line segment in 4 equal parts. Likewise, we may get some more cases. Let's see some example. Find the coordinates of the point of trisection of the line segment joining 2, minus 3 and 4, minus 1. Let the points A 2, minus 3 and B 4, minus 1 and P and Q be the points of trisection. Let's draw the picture. Since P and Q are the points of trisection, P divides AB in the ratio 1 is to 2, or that means AP is to PB equals to 1 is to 2 and Q divides AB in the ratio 2 is to 1, or we can write AQ is to QB equals to 2 is to 1. Here A x1 y1 equals to 2, minus 3 and B x2 y2 equals to 4, minus 1. When P divides AB in the ratio 1 is to 2, that means M1 is to M2 equals to 1 is to 2. The coordinates of P x, y can be written as M1 x2 plus m2x1 whole divided by m1 plus m2, m1y2 plus m2y1 whole divided by m1 plus m2. Or we can write px comma y is nothing but 1 into 4 plus 2 into 2 whole divided by 1 plus 2, 1 into minus 1 plus 2 into minus 3 whole divided by 1 plus 2, or it is nothing but 4 plus 4 by 3, minus 1, minus 3 by 3, which is nothing but 8 by 3, 7 by 3. When q divides AB in the ratio 2 is to 1, that means m1 is to m2 equals 2 is to 1, the coordinates of q can be written as m1x2 plus m2x1 whole divided by m1 plus m2, m1y2 plus m2y1 whole divided by m1 plus m2. For qxy is nothing but 2 into 4 plus 1 into 2 whole divided by 2 plus 1, 2 into minus 1 plus 1 into minus 3 whole divided by 2 plus 1. Or this implies q is equals to 10 by 3, minus 5 by 3. So the coordinates of the point of trisection are 8, 3, 7, 3 and 10 by 3, minus 5 by 3 respectively is the answer. The next is centroid of a triangle. If A x1, y1, B x2, y2 and C x3, y3 are the vertices of triangle ABC, then the centroid is given by x, y equals to x1 plus x2 plus x3 whole divided by 3, y1 plus y2 plus y3 whole divided by 3. Let's draw the picture. So let's see an example. Find the coordinates of the centroid of a triangle whose vertices are 0, 6, 8, 12 and 8, 0. We know that the coordinates of the centroid of a triangle whose vertices are x1, y1, x2, y2 and x3, y3 are x, y, which is equals to x1 plus x2 plus x3 whole divided by 3, y1 plus y2 plus y3 whole divided by 3. So here the given coordinates of the vertices are 0, 6, 8, 12 and 8, 0. So the coordinates of the centroid can be given as x, y equals to 0 plus 8 whole divided by 3, 6 plus 12 plus 0 whole divided by 3. Or it is nothing but 16 by 3, 18 by 3, which is nothing but 16 by 3, 6. Hence the centroid is 16 by 3, 6 is the answer. The points A, B and C are collinear and AB equals to BC. If the coordinates of A, B and C are 3, A, 1, 3 and B, 4 respectively, find the values of A and B. So the given points are A, 3, A, B, 1, 3 and C, B, 4. Also given that AB equals to BC, that means B is the midpoint of CA. So we can write the coordinates of B to be equals to 3 plus B whole divided by 2 and A, plus 4 whole divided by 2, which is equals to 1, 3, or equating to both the axes, both the coordinates of both the axes, we get 3 plus B by 2 equals to 1 and A plus 4 by 2 equals to 3, or 3 plus B equals to 2, A plus 4 equals to 6, or this implies B equals to minus 1 and A equals to 2. So the values of A and B are 2 and minus 1 respectively. The answer. In what ratio will the point 1 by 2, 6 divide the line segment joining the points 3, 5 and minus 7, 9? The line segment joins the point 3, 5 and minus 7, 9. Let the point 1 by 2, 6 divide the line segment in the ratio 1 k is to 1. So using the section formula, we have 1 by 2, 6 equals to 7k plus 3 whole divided by k plus 1, 9k plus 5 whole divided by k plus 1. Now, equating y coordinates on both the sides, we can write 9k plus 5 whole divided by k plus 1 equals to 6, or 9k plus 5 equals to 6k plus 6. On simplifying, we get k equals to 1 by 3. Let's see, k equals to 1 by 3 satisfies the x coordinate or not. The x coordinate is minus 7k plus 3 by whole divided by k plus 1. So we have minus 7 into 1 by 3 plus 3 whole divided by 1 by 3 plus 1. Or it is nothing but minus 7 plus 9 divided by 3 by 4 by 3, or it is 2 by 3 into 3 by 4, which is nothing but 1 by 2, which is the given x coordinate. So here k equals to 1 by 3 satisfies the x coordinate. Thus the required ratio is 1:3. Is the answer. Find the length of the medians of the triangle with vertices 5, 6, 3, 8 and -1, 2. Let the triangle ABC such that A 5, 6, B 3, 8 and C -1, 2. Let the median be AD. Let's draw the picture first to understand in detail. So here A is 5, 6, C -1, 2, B 3, 8 and D, let D be the midpoint of BC and AD is the median. So as D is the midpoint of BC, we can write D, the coordinates of D is dx, y equals to 3 plus -1 whole divided by 2, 8 plus 2 whole divided by 2, or dx, y equals to 1, 5. Now AD equals to x2 minus x1 whole square plus y2 minus y1 whole square whole root over 4, which is nothing but 5 minus 1 whole square plus 6 minus 5 whole square, which is nothing but square root of 17. That means the median AD is 17, square root 17. Similarly, we can find BE equals to square root of 17 and CF equals to 5 root 2. So the medians of the triangle are root 17, root 17 and 5 root 2 is the answer. If x minus 2y plus k is the median of a triangle whose vertices are the points A -1, 3, B 0, 4 and C -5, 2, find the value of k. The given vertices of the triangle are -1, 3, 0, 4 and -5, 2. So the coordinates of the centroid x, y can be written as 1, -1 plus 0, -3 whole divided by 3, -5 whole divided by 3, 3 plus 4 plus 2 whole divided by 3, or it is x, y equals to -2, 3. We know that the medians of a triangle pass through the centroid. So the median x minus 2y plus k must pass through the point -2, 3. That means the point -2, 3 must satisfy the equation x minus 2y plus k equals to 0. So let's put the value of x and y in the given equation. So putting the value of x and y, we get -2 minus 2 into 3 plus k equals to 0, or k equals to 8. Thus the value of k is 8. The answer. Friends, here is a few examples, few questions, but the more and more such questions you practice, the easier it becomes and the more you like it. So friends, keep practicing more and more such questions, and in case you come across any difficult questions, please feel free to share your questions with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your questions. So this was for today's class. Thank you.